All right, so welcome to tonight's lecture. This is lecture 3, and we're still looking at the computer. So today we'll go a little bit further in details. We're going to look at the elements of a computer. And then apart from that, we'll conclude the lecture by looking at how we can convert decimal numbers, meaning from base 10 to hexadecimal, which is base 16. All right, so let's quickly look at the elements of the computer. And before we go in details with the elements of the computer, I would first like to submit to you to say there are two parts, there are two cardinal parts, rather elements of a computer. We have the hardware, and we have the hardware, which is the physical part, and then we also have the software, which is a non-physical part. Yeah, so we have the hardware. The hardware is just a part of the computer that we are able to see with our naked eyes. But the software, yes, we can see it when it has been displayed on the screen, but it's something that is just inside the computer. So we also have to discuss what a software is, but of course today we'll just look at the definition, we'll not go in details. And then I think next time when we meet, we're going to be looking at the software, where we'll discuss the two types of software, which are the application and the system software, which is the operating system. All right, so let's quickly move on. So the computer has physical and non-physical parts, which I'm just talking about. The hardware as the physical and the software as the non-physical. So the software, I talked about the definition of the software. So the software is simply just, this is just a set of instructions, which when put together, they help the computer to execute or to do a certain task. Yeah, so it's the set of instructions. When these instructions are put together, the set of instructions that have been compiled together, and then these instructions, they are there in the computer to execute, or rather to conduct or to accomplish a certain task. Yeah, so that's the simplest definition of a software. We'll look at it in details in the next lesson that we're going to have. So this is what this is what I was just trying to explain. Yeah, and then from there, we'll also look at the hardware. So we said we have two types of computer elements. We have the physical element and the software element. So the hardware element is simple. The hardware is simply just under the physical, the things that we can see. So on the hardware, we have the processing hardware, which consists of the processor and other things that we'll discuss. Yeah, and then the processing software is simply, the processing hardware is simply just the central processing unit. Yeah, so this is, the central processing unit. So the central processing unit, as we earlier discussed, it consists of four many important things. We have the processor, we have the memory unit, we also have the arithmetic and logic unit. So we have the processor itself, where the name processing comes from. So we have the processor. Then apart from the processor, we have the memory unit, which is also a very important part of the computer. So we've been singing these songs. And then apart from that, we have the ALU, which is just the arithmetic and logic unit. And then apart from that, we also have the control unit. It's also part of the processing part, the control unit. All right, so let's just look at them in details one by one. So let's first talk about the processing hardware. So the processing hardware includes the processor, the main memory, and the buses. And then apart from that, it is a part of a computer that carries out the instructions of a computer program. And then it is the unit that reads and executes program instructions. Hence, it is known as the brain of a computer. Yeah, so the CPU consists of the storage and memory unit and arithmetic, logic unit, and the control unit. So we talked about this. Yeah, so we look at the processor. This is just a highly complex, extensive of electronic circuitry that executes programs and instructions stored in the main memory. So the processor is just there to, okay, it's just there to execute programs and instructions stored in the main memory. In other words, it's just there to process the instructions. It's just there to process the instructions in the main memory. The main memory will be there to store the instructions, or rather to store data or information. But the one that processes the data, which is in the main memory, is the one that is called the processor. And you have to understand to say there are two types of memories. There's volatile and non-volatile. So volatile memory is the one that easily loses information when it is not connected, when power has been connected from the laptop or a computer. Yeah, so the non-volatile is the one that stores information, whether the computer is on or off, to still store information. But a volatile memory will always depend on power. So we're going to discuss that. I think it's there in the next lecture, or maybe in this one. Okay, so let's look at the memory unit. So this is also just a circuitry that holds and programs, that holds instructions and programs on a computer. So the memory unit is there just to hold instructions and programs in the computer. Yeah, it is also known as the primary storage, or the main memory. Yeah, so it stores data, program instructions, internal results, and final output temporarily before it is sent to an appropriate output device. Yeah, so before data is sent to the output device, it is first stored in the memory. So it will either be stored in the volatile, or rather it will be stored in both the volatile and the non-volatile. Yeah, so mostly the information that is stored in the in the volatile are just the running program. So this volatile memory is simply just the RAM. And then the ROM is the non-volatile. The ROM consists of the hard drive, the storage devices that you can use to store data for a long period of time. So we'll discuss all those things. So it consists of 1,000 cells called storage locations. Volatile memory that does not hold information permanently, it loses all the information when power is switched off. So I talked about the volatile, which loses information and when the power is switched off, meaning it depends on power. This is just the RAM. That's why in laptops, in portable computers, they mostly make sure that they put in a very small battery, rather a capacitor of some sort. It will be keeping power when you switch off the computer. It will at least help the volatile memory to keep at least a certain amount of data, so that the next time you switch on the computer, you, instead of maybe starting over from scratch, if you are doing something, at least you start from somewhere. It would have saved some information. Yeah, but those old computers, they were like, if you switch it off, then everything goes. You have to restart as long as you didn't save in the non-volatile memory. So these cells activate with on and off. So in computers, when you hear about on and off, the first thing that should come in your mind is 0 and 1. So 0 is off, 1 is on. That's what it means. These are just binary numbers, binary digits. So thus a character, either a letter or numerical digit, is stored as a string of 0 and 1 binary digits. These are called bits. These bits are used to store instructions and data by their combinations. Okay, so this last point here, what it means is that the bits are used to store data in the computer by combinations, meaning there is a way in which they are going to be combined. So these are normally used to numbers and letters. When you press, for instance, on the keyboard, letter R has its own combinations of these 0 and 1s. So we, for instance, maybe if you want to press maybe M, I'm just giving an example, I'm not saying it's the actual combination. Maybe you might find it's something like 0, 1, 1, 0, 0, 1, 0. Maybe that's for, sorry, let me do this. Maybe that's just for letter R. So that's what it means in short. You just combine 0 and 1s to come up with the characters, the respective characters. Okay, I'm sure maybe if it's one of the topics in your handout, we'll discuss it. All right, so let's also look at the arithmetic and logic unit. So this one, as we discussed, it's only there to, so it's there in the computer to just help you to carry out all the arithmetic operations, all the arithmetic operations and logic operations. So when you talk about arithmetic operations, we're talking about subtractions and addition, all those mathematical operations. But when we talk about logical operations, these are just there to, okay, I think these are just there to, I mean, logic, to give logic information about something like determining whether it's male, female, or if not that, maybe, okay, in short, when you talk about logic, for instance, logic gates, when you're discussing logic gates, you only talk about two things there. It's either true. If it's not true, then it's false. There's nothing like in between. Then it's false. So for male, female, it will either be male or female. There's nothing like male, female. Yeah, so these are the kinds of information that are executed by the arithmetic logic unit. Yeah, so this is what is exactly under the arithmetic logic unit. All right, so it is the unit where all arithmetic operations like addition, subtraction, and logic functions such as true or false, male or female are performed. So I've talked about this. Once data are fed into the main memory from the input devices, they are held and transferred as needed to the arithmetic logic unit, where processing takes place. So this is why it's under the processor. It also processes a certain type of information in the computer system, in the computer in short. So its main purpose is just to process the arithmetic and logic functions. That's all. So no processes occur in primary storage. Intermediate generated results in the ALU are temporary, are placed in the memory until needed at a later time. Yeah, so they are temporarily stored in the memory. Yeah, until needed at a later time. What does this mean? So meaning most of these instructions that are conducted, or most of these operations that are in the ALU, they are mostly stored in the RAM. Yeah, they are mostly stored in the RAM, not really in the ROM. In the ROM, unless maybe there's an option of you saving to store them for a long period of time. Otherwise, they are stored in the RAM so that if you need to use them at a later time, you can easily use them. That's why you find, for instance, a calculator, a program, a calculator program on the laptop or on a desktop or any computer. It stores a certain amount of data so that, for instance, if you press maybe 2 times 3, it will give you the answer 6. But that 6, when you delete, you think it has gone. If you want to reuse that 6, you can just press answer times 3. Then it will give you 18, meaning to multiply your answer, which is 6 times 3, then to give you 18, meaning it had stored that 6 somewhere. Where? In the RAM. That's what they mean here. So data may move from primary memory to ALU and back again to the storage many times before the process is finalized. Okay, let's also now look at the control unit as well. So the control unit, as we also discussed, we discussed about this briefly, where we said it just acts as the, okay, on the control unit, we said it's just there to it's just there to coordinate the input and the output devices of the system. Yeah, so it's just there to give to coordinate, rather to just, how can I put it? All right, so the control unit is just there to coordinate the input and output devices of the system, meaning it's there to help you to get, to interpret the instructions from the input devices into the into the processing process. And then from there, it will also help you again to interpret that same information from the computer language now to something that can be understood by humans. Yeah, something that can be outputted, something that will be understood by the users. Yeah, that's what it does. So that's why sometimes it's called the central nervous system of a computer, and it ensures that the information is stored correctly and the program instructions are followed. The program instructions are followed in proper sequence, as well as the data are selected from the memory as necessary. So it also ensures that the program instructions are followed. So apart from coordinating the input and the output devices of the system, it also ensures that all the instructions of a given program are followed in a proper sequence, because every program is programmed, rather it's made in such a way that it has to follow certain instructions for it to work or for it to execute a certain task. Yeah, it doesn't just do things anyhow. It has to follow a certain order. So the work of the central unit is also to make sure that these make sure that these programs instructions are followed in a proper sequence. Yeah, and it also coordinates all the input and the output devices of a system. So let's look at these input and output devices. That's what we're going to conclude with for tonight. And then from there, we do that last question. Then after doing the last question, next time when we meet, we're going to look at the software and we're going to look at the softwares and the types of softwares, and then we'll go in details from that. All right, so the input devices are hardware used to provide data instructions to a computer. So I've been singing this song as well. We've been talking about the input devices almost every day. We discuss computers. So these are just devices. They are usually hardware devices that are used to provide data instructions to a computer. So these input devices, examples of these are keyboards. We have the mouse, we have, okay, there are a lot in short. We have scanners, yeah. And then they convert data from human sensible into a machine sensible. So meaning the opposite of this is the output. The output device will convert from machine sensible to human sensible. But input devices will convert from human sensible information into the machine sensible. So what you're going to press on the keyboard is letter R, but according to the device that you have, which is the keyboard for you, letter R will just be letter R on the keyboard. But for the keyboard, according to the instructions that has been given to it, maybe you find that this letter R is written as 100101. That is the computer language. Yeah, or that is the computer sensible form. That's what it means. And then these input devices, examples, we have the keyboard, we have the mouse, the scanner, the microphone, the web camera, we have the joysticks, and we have the touch screens. Yeah, we have the MICR, which is the magnetic ink character reader. Then we have scan. I mean, these magnetic ink characters are just used to for scanning checks. Then we have OMR, which is the optical mark reader. Also have the OCR, which is the optical character reader. We also have the barcode readers, which are also used to scan product codes. Yeah, so all these are examples of input devices. Let's also look at the output devices. So remember, we said output devices will will convert information from a computer sensible information to a human sensible information. So to a computer, that information might make sense, but when you just take it direct to a human being, it will not make sense. So there has to be a device that will convert something that is not making sense to a human being to something that will make sense. So this device is the one that we call the output hardware or the output device. So output devices convert electronic bits of data stored in the computer into a form understandable by humans and computer control services. Okay, so this is self-explanatory. So output is displayed to a user 25 in the number or different media, including graphics, audio. How is this statement? Output is displayed to the user in the number of different media, including graphics, audio, video, or text. So in short, the outputs, what we usually get from the screen, we can get graphics, and then we can also get the audio using our ears, and then the video is also gotten from the screen, even the text from the screen or hard copy paper. Yeah. So this is achieved by the use of printers, which is the hard copy. If you're getting a hard copy paper, meaning we're going to use a printer. Then screens, which is floppy, and then we have the computer output, microfilm, blotter, and then we also have the VR, which is the virtual reality helmets. Okay. So any device that is capable of representing information on a computer is called the output device. So any device that is able to convert computer sensible information into human sensible information is called the output device. So output devices receive information from the CPU and present it to the user in the desired form. So examples are terminals, or it's a terminal or a monitor. So a monitor is simply just a screen of a computer or any. Yeah, let me just generalize it. A screen of a computer is called a monitor. And then the other example is the printer. And then we also have headphones, which gives us audio output. Okay, so now let's look at the last exercise here, where we're going to be converting a number from base 10 to hexadecimal. So let me start first by saying any number that you see without any base indicated on it is always in base 10. So if we write maybe 10, 10, 1 without including down there to say this is in base 2, you can also consider this to be in base 10 if there is nothing like that. So if we write 205 without including the base here, whether it's base 8, so base 8 is called octal. So whether it's base 8, whether it's base 16, it's base 5, it's base 1, as long as we have not added any base here, then no to say it's in base 10. So when we write 57 like the way it is, we just say convert 57 to hexadecimal number. Then this 57 is in base 10. That's how it is. And then remember what we said last time when we were solving that question. We said hexadecimal number is simply just a combination of two numbers. This hexadecimal is a combination of two words rather. Hexa from 6, so hexa from 6, and then decimal, which means 10. So deci itself means 10. So 10. So when you say hexadecimal, we're talking about base 16. So same applies to saying hexa. Let me say this, octodecimal. Octo means 8. So when you say octodecimal, this is just base 18. So that's what it means. So we have a lot of different numbers. So let's now learn how to convert from base 10, which is decimal, to hexadecimal. So we have 57, which is in base 10. So now we have to convert this to hexadecimal. So now how do we do that? So this is simple and straightforward. We're converting this to hexadecimal, so we're going to write 57 there. We're going to use successive divisions. So I'm going to generally tell you to say, every time you're converting a number from, from base 10 to any base, you just use successive division. It works for all the numbers. So for instance, we are converting 57 to hexadecimal. So hexadecimal is simply just base 16. So we'll just write 16 there, and then we begin to divide. So we say 16 into 57. So 16 into 57, the answer will simply just be 3. So the answer will just be 3. Then we're going to be writing the remainders this side. So let me put R on top there. So the remainder will simply just be 9. So when you divide this into 57, the answer will be 3 remainder 9. Then when you divide 16 into 3, the answer will be 0 remainder. This will now be, when you divide this into 3, the answer will just be 0, and then we say remainder